Hello, and thank you for joining us today for the third joint SWAN North American Alliance and Frost & Sullivan's webinar. Today's event is titled SWAN North American Alliance, Delivering Smart Wastewater Network Solutions. My name is Anna, and I oversee Frost & Sullivan's growth, innovation, and leadership briefings. Before we begin our event today, I'd like to go over a few quick notes. This presentation will be available immediately on demand, and you can view it at the conclusion of the webinar. We encourage you to ask questions throughout the presentation, and you can do that by clicking on the Ask a Question button. You can also safely share this briefing at any time by clicking on the Share button. We will have some detailed slides on today's presentation, so there's a full screen feature available to you at the bottom right-hand corner of the screen. Our moderator today is Seth Cutler, Senior Industry Analyst for Frost & Sullivan's Energy and Environment Group. Our speakers today are Elkin Hernandez, Manager, Process Control, DC Water, Ting Lu, Principal Engineer, Clean Water Services, and Ken Thompson, Senior Technology Fellow, CH2M. With that, I would now like to hand the presentation over to Seth.
Great. Thank you very much, Anna, and thanks everyone for joining in today. It's a great time that we can bring the SWAN North American Alliance and get a lot of key speakers and insightful stakeholders of the industry together so we can look at some of the innovation solutions and directions we have going forward within smart wastewater networks. Oftentimes we talk about smart water, things get a little bit more towards the distribution networks and drinking water, but what we wanted to do is ensure that we had a session looking at wastewater. Just to quickly look at the agenda for today. So I'll first do a little bit of an update around the Alliance, our current events and the annual workshop that's coming up. After that, we'll have Elkin Hernandez talk about DC water and smart water at the Blue Plain Advanced Wastewater Treatment Plant. As a quick introduction for Elkin, Mr. Elkin Hernandez is the Manager of Process Control at DC Water's Blue Plains Advanced Wastewater Treatment Plant, and he's responsible for all of the instrumentation and control at the plant. Mr. Hernandez has 18 years of experience in design, construction, and commissioning of large and complex process control systems. He has worked in research on telecommunication protocol interoperability, as well as in the field of alarm management. More recently, his work is focused in the fields of process optimization, data analytics, prognostics, and cybersecurity. He has utility, consulting, and industry experience that ranges from treatment plants to commissioning large and complex water and hydroelectric power projects across the world. Mr. Hernandez holds a master's and bachelor's degrees in electrical engineering and computer science. After Elkin's finished speaking, we'll then hear from Ting Lu as she talks about using real-time control and data management for stormwater management at Clean Water Services. Dr. Ting Lu is the principal engineer at Clean Water Services in Oregon. She received her PhD at the University of Cincinnati. Dr. Lu led the district-wide integrated planning development for holistic watershed improvement projects, including water quality monitoring, intelligent water system initiatives, system-wide optimization within watershed and watershed assessment from an outcome perspective. Prior to joining Clean Water Services, Dr. Lu worked for both Metropolitan Sewer District of Greater Cincinnati and Black & Veatch. Her goal is to cost-effectively address pollution reduction and water quality improvements through a holistic watershed approach and intelligent systems. Dr. Lu is a member of the Water Environment and Research Foundation Sensor Challenge Issue Area Team. She's chair of the Water Environment and Research Foundation Intelligent Water System Focus Group and a member of the Watershed Management Committee, Utility Management Committee, and Intelligent Water Technology Committee at the Water Environment Federation. Dr. Lu is a highly accomplished environmental engineer and scientist who has authored over 100 papers and presentations nationally and internationally. She has co-authored several book chapters and white papers, including Envisioning the Digital Utility of the Future for the NACWA Task Force and Intelligent Water System, The Path to a Smart Utility for WEF, LIFT, and WERF. After that, we'll have Ken Thompson join us to talk about the SWAN interactive architecture tool applied to wastewater utilities and facilities. Ken has 37 years of experience in the water industry and is a senior technology fellow for CH2M in their Denver office. He serves as the global technology leader for smart cities and sensors, which includes the design and implementation of surveillance and response systems in water distribution systems. This falls under the Intelligent Systems practice area that encompasses all aspects of big data analytics and smart systems. Ken previously served as the global technology leader for the Integrated Security and Emergency Preparedness team and managed vulnerability assessment, emergency response planning, and security design projects for over 100 water and wastewater utilities, and assisted in the development of numerous national security guidance documents for the North American water and wastewater industry. Ken is a member of the AWWA, chairing the New Information Technology and Research Committee, One Water Task Force Chair for the Smart Cities Council, and President for the Smart Water Networks Council. After Ken is finished, we can then address some audience Q&As. So just to kick things off, I want to remind those that know or perhaps are unaware that we're having our second annual workshop in Chicago on November 6th. This is being hosted by Uptake in Chicago. The workshop is being held in coordination with the Alliance for Water Efficiency, Current, and Global Waterworks. Additionally, there will be an evening reception sponsored by Census. This event builds on our first workshop held in January earlier this year at Qualcomm in San Diego. That day was a great success. It attracted over 200 individuals who are interested in learning more about key smart water issues to help improve utility operations going forward. For a little more detail on the event coming up and the agenda, we have a morning of 2 in-depth panel discussions, one utility-led and the other industry-led. The panels offer a great time to get experts up on stage to discuss a range of challenges and opportunities, but really driven by the audience and those in attendance asking questions and determining the agenda. So it's a great time to ensure people coming get a chance to discuss topics that are of importance to them. Lunch will have a series of roundtable discussions with each table focused on a specific smart water challenge or opportunity. In the afternoon, there will be 3 sessions focused on urban flooding, water quality, and digital transformation. These sessions are of Midwestern relevance, but also certainly to the rest of North America, dealing with issues around urban and basement flooding, water quality monitoring, trying to really lay out a larger digital strategy focused on current opportunities, but also thinking about strategic visions for planning. A few of the speakers that will be there on the day include David St. Pierre, who's the Executive Director at the Metropolitan Water Reclamation District of Chicago, Tom Heikkinen, General Manager of the Madison Water Utility, Corey Williams, President and CEO of Optomatics, David Logston, Senior Director of Public Advocacy at CompTIA, and Gary Wong, Principal at OSI Soft. So I invite everyone to look at the event registration link and hope you can join us. If there are any questions, do feel free to reach out to myself. My email is Seth, seth.cutler, C-U-T-L-E-R, @frost.com, and I can certainly help you out. Additionally, we do want to highlight key utility smart water successes, and I invite utilities on the line or who review this webinar later to get in touch with me if they have an interest in sharing their specific actions and plans around smart water at the workshop, and I can see if there's a space on the agenda. At this time, I'm happy to pass it off to Elkin Hernandez at DC Water, and he can talk about the wastewater treatment plant.
Hello, this is Elkin Hernandez. I'm with DC Water, and I'll be sharing with you during 10 minutes the experience that we had here at Blue Plains and how it relates to smart water. So, quick introduction. Blue Plains is an advanced wastewater treatment plant. Currently, our rated capacity is 391 MGD. We serve DC and Maryland, some areas of Maryland and Virginia. So we're an authority that goes across different jurisdictions. The plant performs advanced secondary treatment, nitrification, denitrification, and filtration as well. Recently, we got in service terminal hydrolysis, and currently we're undergoing a significant expansion including collection tunnels and a treatment capacity for about $3 billion. That's ongoing work on the plant. So the way I decided to run this presentation was by sharing with you guys a couple of the cases of where we have used technologies that we consider smart water, and how that and at the end I'll be sharing with you my conclusions and how we feel so far about this journey, which started approximately 2 years ago. So the first case will be very quick. Is based on our multimedia filters. These are sand and anthracite filters that we use for effluents. We have about 40 of them, and we have been experiencing issues with these filters. We have breakage in the under drains, which for anybody familiar with filters means very expensive reconstruction of the filters. And we couldn't, we've been learning about these breakages as they become, let's say, catastrophic. We have bigger spills of media going into spent water wells, and they're not being very, very traumatic and expensive. So we knew that we have collected data for about 10 years on these filters, since we have a running control system. And we say, well, everybody's talking about big data. What can we do here with this information we collected to help us do things in a better way? So we partnered with the University of Cincinnati to have a data scientist, and we run an exercise to perform analytics on these filters. So what you see on the slide is basically a quick description of the process. This is a backwash system that is performed every 24 hours. And we, as indicated on the slides, we have find defects that are basically short-circuiting the filters for practical purposes. This was our very first try on big analytics. So we partnered with this data scientist and went through the different steps of doing data analytics. And as we learned, we went to a step of data preparation, in which the data is collected. Keep in mind, this data scientist is not necessarily process savvy, so you have to explain to him what the ranges mean, what the values mean, how the process works. Then, based on the information we get on the nature of the process, you perform something called feature extraction. That could be time domain, could be frequency domain, could be a mix of both. This is where it starts getting a little bit more complicated. In our case, we came with the conclusion that time domain was enough. So when we're talking about time domain, it means we just need to do very simple means, medians, maximum, minimums, standard deviations to try to make sense of the data. After that, and we have to do the feature extraction, we do a feature selection. So to understand which features provide value to understand the process and what can go wrong in this process. So this is basically creating signatures, creating the signatures for normal operations, signature for failures, and that way we can perform a health assessment. Then, and actually the graphics that you see here in the slides are actual graphics that were produced out of these reports. We got those signatures, and we analyzed the data in the context of given filters. So outcome was we were able to correlate data like head loss on the filters and backwash flows to understand, at least identify the very moment the filter starts to malfunction. So we were not so far been able to predict the failure, but we've been able to identify it right away, which has an advantage for us because we can take the filter out of service and avoid having to clean up spent water filters, wells that won't be receiving these excess sand or anthracite. So for us, it's been a successful exercise. Keep in mind that the initial The goal was to predict the failure. We didn't get there, but we got what I consider to be a useful result. Next, this is very simple. We on the treatment side, we have a lot of vertical assets, and those assets, in some cases, are connected to control systems. Control systems, traditional control systems, end up being very expensive when it comes to monitoring. So you can only justify it on certain value assets. So if you have a pump that is worth $100,000, very easily to justify having vibration system, having energy monitoring, and so on, because it's an expensive asset. You can spend $5,000, $10,000 to do this monitoring. But when you have a pump that is lower value, we're talking $5,000, it becomes harder for you to justify. Say, well, I'm going to spend $5,000 to monitor something that is worth $5,000. So what we have found is that there is a big opportunity for new technologies that are inexpensive and very flexible to fill these gaps. So what you see on the slides are actual apps that we have deployed to monitor energy out of our RAS pumps. So this has been an actual example of what is being done. In one case, you can see we're monitoring vibration, flow, temperature, and current. In other case, we're only monitoring current, which those measurements properly analyzed can tell you a lot about an asset. And this next slide give you a good idea on how we are trying to do the approach from the architecture perspective. We are using a low power, wide area sensor. So we're being experimented with LoRa networks. We've been evaluating Sigfox. We've been evaluating LoRaWAN as well as traditional means of communication to figure out what is the best fit for us. Something to note is that I think we are very early in the stage of smart water, so the options are many, and it's for the users. It's up to the users to try to find out what is more effective. So this is just an example of how you can connect different trains and types of data and leverage them on a single backend. In this case, we'll say it could be a server or a cloud-based system. The apps that you saw previously were being run on a cloud-based system, and that seems to be a good solution when you don't have concerns about cybersecurity, when you're not controlling critical assets, and where you're not concerned about the integrity, the privacy of the data. You're not sharing anything. You're concerned about being stolen and shared somewhere else. So what I wanted to do there is to give you quickly two examples, and now I want to spend the last few minutes on more of a big picture. The last minute on the most of a big picture. So what have we learned so far during this journey? We learned that the technical staff is medium difficulty. It's not easy. You need PhD students. You need people who can do data analysis, and those are usually highly skilled people. You don't have them. You need consultants that are savvy and experienced on the items, on the topic. So but that has not been the hardest part for us to get. Then you have the strategic overview. That's a little bit harder because that needs to be set up from the top, and it has to be clear and realistic. You cannot expect that you overnight will change all your operations just because you're doing a smart water. It's a process. It's a process to find the opportunities, what works for you, and what you can actually deliver in a way that is sustainable. Right now, you have a lot of boutique vendors, a lot of boutique solutions. Question will be, how sustainable are all these? How are you going to plan to make them work in the long term? Again, practical staff gets even harder when it comes to practical staff. And when it comes to commitment, it comes even harder because in many cases, you don't have the staff dedicated just to do this within the utility. So if you don't have quick results, if you don't have clear goals and wins, the whole organization may become just exhausted and, drop the ball. and that way you don't have a sustainable strategy. This is a paradigm in changing culture, so you need to understand that doing smart water means you change the way you run business. You also need to understand that we work with humans, and these humans have to be empowered for us to make the best use of these technologies. So it's a change in the way we operate. We need to have everybody directly involved at the level that is pertinent to them, and we have to not underestimate the human factor on the utilization of these technologies. With that said, I'll short. I think I don't want to go much over my time. If you have any questions, you can ask me at the end of the presentations, or you can email me. My email address is there. And with that said, now I'm going to turn it to Ting. Thank you.
Thank you, Elkin. So hello, everyone. So I'm really glad to be here. So in order to demonstrate the value of smart systems, I'm going to take you from process control within a wastewater plant to how to using real-time control and data management for stormwater management within a watershed scale. So just a little bit background about the Clean Water Services. We are a regional wastewater and stormwater utility and working with many members and serving a population over 500,000 and operate 4 advanced treatment plants and implement the MS4 stormwater program, as well as managing the surface water and the water planning long-term goal as well. So we're located near the Portland city and on the West Coast. So just like any typical utilities, the daily operations involve the pumps and pipes and plants, but how to really achieving that watershed health and overall environmental outcome is our Clean Water Services mission. And what we have done through innovation is we started the first world the phosphorus recovery facility here. And in order to advance the water reuse, and we started the high purity water to brewing beer with the reused water. And also some of the water management, not only the water quality, but also water quantity management. And all of this is about environmental outcomes and that connecting natural systems and connecting great infrastructures and to enhance the ecological enhancement and the quality of life. So in order to do this, it really requires the innovation to push that envelope and to achieve that outcome. So today I'm going to really demonstrate innovation in terms of smart systems. So here is our reference model that we have developed based on the Cisco's Internet of Things, as well as SWAN research tool that Ken is going to talk about in detail later. So what we have developed here is the first is the physical infrastructure. So this is where we have all this physical asset like pipelines and pump stations or any streams and lakes. And then the second layer for the smart platform is the sensing and control. So that's where you can have your meters and monitors and to really getting that real-time data. The third layer is the collection and communication. And Elkin talked a lot on that and through RTC and different ways of the communication method and protocols. The fourth layer is the data management and display. So this is getting to the end user, such as SCADA, GIS, and application software and this stuff. So the real power of the smart system that turns data into information is happen during the fifth layer and sixth layer. So the fifth layer is called the data visualization and the visibility. So this is really you can perform your business intelligence and using data cubes and really having that raw data and forming the trend and give you alert and trendings and what's going on with the physical assets. And the sixth layer that we see is very important on the district level that we need to have this collaboration process so that wastewater process have an impact on the conveyance and vice versa. How do we collaboratively having that information and making a better decision and to support the overall mission? So with these 6 layers, I'm going to talk about just on the stormwater itself. So this is what we have on the smart water system. This is a typical detention pond within a community, and there is our goal is trying to actively managing the stormwater runoff by having this valve that can release actively control the release rate where the runoff is going to the creek. So the technology involves the way using the weather forecast data and also some other rain gauge data, and that's going to get into the cloud communication and analytics. So working with the OPTI and geosyntax, and there are the on-site sensors and such as the water level sensors, and there is the cameras real time, and also the valve that can really actively controlling how much water is releasing to the pond. And at the end, you have this end user platform. You can really real-time accessing the data and saying how much rain is going to come, how much runoff is going to be generated, what is the release rate that the system needs to be in order to produce that minimum release to not interrupt the receiving streams. So here is a performance hydrograph. So this is the rain event happened during the May last year. So basically, the green shows the peak rain event, the storm event during that wait time period. As you can imagine, the inflow that is really mimic what's the rain coming. So there are quite several peaks runoff that come into this detention basin. But what the smart water system really helped is by calculating how much rain is coming and how much is going to come in the next 24, 60, 36 hours, and they can actively storing the water as well as dampen that hydrograph that goes to the receiving stream. So you can see even though there's a peak runoff coming to the pond, but by having this data analytics, the receiving stream really receive a minimum, a very flat hydrograph throughout the entire rain event, and which is very important to protecting the receiving stream and the function of the creeks. So just to summarize the benefit of smart systems, and it's really when you're selecting the smart system, it needs to support the overall mission outcomes. I think we are here not only because the technology is cool, but it's because it can utilize data and technology to really maximize that capacity of the detention basin in this case, and also improve the environmental outcomes that really reduce that disturbance and minimize the change of the rate that go into the receiving streams. The second benefit is the controlled spending and leverage partnerships. With this project particularly, we were able to work with the developers in the neighborhood. They are very interested in these smart technologies. And because of this active control, we are able to reduce the infrastructure footprint, and which translates to the cost eventually. And the third element of the smart system is flexible and adaptive management. What that means is because the data analytics actively looking for how much rain is coming every minute, they are calculating how much storage you need because of this runoff generated, and using adaptive management protocol for stormwater management rather than just when you have an event, you are going to apply just one way of managing stormwater management. So we are where we are is that we have successfully demonstrated the value and knows the value to the district with a single individual RTC site. And what we are doing now is really having this distributed RTCs along the entire creeks, and also install creek gauges and other local data, and really to having that from an individual project side to a system integration. So that way you have more control, not only just with the one community, but you have the downstream creeks that may offer a better flexibility to control the stormwater runoff. Because what you are protecting is not a particular section of the creek, but the entire reach and overall the entire watershed. So that gives really a great flexibility with the system integration. So overall, the vision where we are headed is this holistic watershed planning and operation. So I talked about from project site level to a stream reach level. Where we are heading to is this holistic watershed level. So we have these 5 layers that we are connecting together. So you have your above ground infrastructure. This is all the different stormwater runoff facilities and green infrastructures. And there is your underground sanitary sewer pipes and asset. And what's that response going to cause the impact on the water resources recovery facilities? And then what is the impact to the receiving streams, and ultimately translating to the customer experience, what the customer is going to get the information, this transparent, active, proactive action items, and gaining that confidence from the utilities. So we are using smart systems and data analytics and to connecting all these 5 layers together to really achieve that overall outcome I talked about. So with that, and if you have any further questions, please feel free to contact me, and I will hand it over to Ken.
Great, thank you very much, Ting. It's a pleasure to be here today and be talking on the same panel as some of my friends, Ting, Elkin, and Seth. When you talk about the SWAN Interactive Architecture Tool, it's all about planning, and it was really great to hear Elkin talk about the strategic overview and the difficulty in putting that together, and Ting talking about their holistic approach to watershed management. Because what we talk about a lot is, what we see a lot in the industry are individual boutique solutions being put in place without this advanced thought process and vision of what their overall system should look like at the end of the day. And what happens by taking that approach is you end up with a number of different solutions out there that can never be integrated together in an effective holistic approach for your system. So the upfront planning is very critical, and that's really what the work that SWAN's been doing is all about. We started developing these different tools in 2014 with the water and then the wastewater. They're available free of charge for anyone to use, and the idea is to help you start that process of what your system should look like. There's a bunch of tools you can look at. First one is evaluating your smart water network, and through a questionnaire, it gives you a SWAN Smart Score. And that score gives you an idea in terms of where you are along the progression from creating a more intelligent system for your company. You also need to identify your business drivers, and the business drivers are going to impact your vision, what you really want to put in place at the end of the day to make your system meet the new goals that you have to meet for your organization. Understanding the business drivers, the challenge areas is critical so you can focus in the most high value areas for your organization, looking at technical solutions, and then finding providers that could help you proceed along the journey. We've had a number of utilities across the world use the different tools. Rick Scott from Seattle Public Utilities, Mike Bishop from Welsh Water, Adrian Bird from Unity Water in Queensland, Australia. And they've all got different benefits from using it, and we'd encourage you all to go in there, look at the different tools, and start to help to advance your systems. I'd like to talk a little bit about the Wastewater Network Management Tool, which was just introduced in May this year at the SWAN Annual Conference in London. And when we put this tool together, we used the same level of tiered process that Ting talked about, with starting with your assets and going up to your data visualization in level 5. And what this allows you to do is look at your type of system you have, whether it's a gravity sewer, pressure sewer, combined sewer, and where you can start to collect information and to be able to make better decisions in how your your system's functioning and to meet some of the goals of minimizing CSO discharges, improving water quality in your system, reducing dry and wet weather overflows. All things that tend to cause utilities a big headache. Before CH2ML, I worked 20 years on the utility side, and I understand the challenges utilities go through. And this, with the new technology in place this year, you can really just do some amazing new things. If you click on one of these green buttons, like database, you'll get more information about that tool and some things you should be looking at when you start to develop your process. Example, in the database, it tells you what the function is. The overall goal of a smart system is taking data, creating information, creating knowledge, and be able to take rapid action. And this is accomplished through the whole process of collecting it, communicating it, processing it, and visualizing it. And to be able to do that, you've got to have a robust system in place. And a database is a key area that requires you can capture data from different streams, you can store it in a normalized fashion, so you can start to cross-reference that data together to show relationships. And the relationships are really where you start to create that knowledge of your system that allows you to take rapid action to prevent failure or problems from arising. Nice thing about the wastewater network management tool and the water one as well is we've got a whole series of different types of case studies in there. These example 4 of them where you, one being the CSO work in Cincinnati, Ohio, where they've been doing a massive program on looking at a watershed-wide approach for reducing CSO discharges in their system. And you can click on it and get more references from the more information about how they've accomplished that. In fact, they'll be doing a presentation at the SWAN Pavilion workshop at WEFTech, at a workshop for our WRF project, and then also at the November 6th event. So you'll be able to hear more from Cincinnati about what they're doing in a number of areas. Optimizing sewer maintenance in San Antonio, Texas, using smart cover system, long-term control optimization with Optimatics, lift station control, and monitoring some work Zion's been doing. So what this allows you to do is to see real proofs of how technology is being used and implemented and the value that the utilities have gotten out of that. And that's really important. We get a lot of people coming up to us saying, I got this great new solution, but it's never been tried before. And I think what we all want to see from the utility perspective is how my peer utilities used it, what's their value, and how can that be applied to the challenges that I have to work on today. So if you really want to learn more, please visit the SWAN forum, www.swan/forum.com. I'd like to also put in a plug for a project that SWAN Clean Water Services and CH2M are working on. It's with the Water Environment Research Foundation. It looks at urban sewershed monitoring and also big data analytics. We currently have 2 surveys out on the street. We're looking for utilities and technology providers to fill out. So if you have any interest, please email me directly, and I'll get you linked up to the survey. We're also going to have a workshop on October 6th, Friday after WEFTech, to take the survey results and to start develop use cases, which will lead into a demonstration project next year to really start to develop more proofs of how technology can be used to improve and meet the challenges of the industry. With that, I'd like to turn it back over to Seth.
Wonderful. Thank you, Ken. And thanks everyone for those examples. And I think that was a good way to close off and round off the presentations by looking at the architecture tool, and I certainly invite everyone to explore that tool online, try to test some of your situations and explore that. So what we'd like to do now is just to move over to the question and answer session. We can spend maybe 10 or 15 minutes on this, and we can look at a few different questions. So again, like Anna said at the start, feel free to use the Ask a Question button to put in a question, and we can go through those. With what we have now, and just to kick things off, I think it would be good to ask our panel, where do each of you think we are in the current smart water or smart wastewater journey? It's a little bit broad, but could be good to kick off the discussion. Elkin, do you want to start?
Of course, Seth. I believe we're in the very earliest stages. If you compare, just go for smart metering. If you compare smart metering, I think the power industry is a few years ahead of us. Things like smart metering or just network monitoring are becoming more prevalent in water, but we're just a few years into. And I think more than that, there's this huge potential on other aspects of the water treatment, sewage systems, as Ting is mentioning, and that need to be explored. And I guess still we have some challenges ahead that are holding us from speeding up those developments. Hopefully, places like SWAN can help us bring up that cooperation among different parties, vendors, consultants, utilities, universities, to speed up that cooperation and make things happen faster.
Great, thanks. Ting or Ken, do you have any comments to that question in terms of the overall smart water journey?
Yeah, I think just echoing what Elkin is saying, I think we are not to the fully where we can utilize the smart system yet. I do see pieces here and there, like within the wastewater plant, DC Water has done a wonderful job and utilize that a lot. And also like a convenience, like Ken was mentioning some of the smart cover or CSO controls. I think the direction is going to be how do we integrate this information across the district level. And also, I think from a technology side, and how does this system interconnect it together, and that gets into a huge interoperability topic that I know that we want to really having the system connecting with each other. And also utilize the data into the full potential as possible. A lot of data, like for instance, for our RTC Stormwater, we utilize the real-time weather data, but that could also be used to optimize the wastewater plant operation. So how can we really leverage that resources is another key area we should, the industry can really push to.
Yeah, let me quickly add to that. I agree that I think smart water is definitely further along than smart wastewater right now. There's been a lot of work done in data analytics with water quality, AMI metering technology that really has helped to advance that process. There's still a lack of integration though, even on the water side. But more interesting than that, what we're seeing now on smart cities, there's an approach now to start to make sure they're integrating water and wastewater into their smart cities program, because they're finally realizing that you can put smart street lights and smart parking in place, but if you don't have water, you don't have wastewater, you don't have a city. So groups like City of Bellevue, Washington, they're actually developing a holistic city portal that includes water and wastewater in it that can be shared across departments. So if they've got a pipeline break, police and fire and street repairs know about it real time. And that's going to help them to manage their overall city operations better as well. So there are some great advancements happening, but we've got a long ways to go. And I think a lot of challenges that Elkin and Ting brought up in terms of the planning, the implementation, and being able to have that commitment are ones that we've got to continue to overcome. It's like creating a new culture in the utility. We've gone through the safety culture, we've gone through the security culture. Now we need to implement a smart system culture, and that's going to probably be pushed by the younger generation that have grown up with cell phones and tablets as they're young kids, and they'll be the ones that actually insist that we become smarter in our industry.
Perfect. Thanks, everyone. Ting, this next one is from you that came in. I think during your presentation, just a bit of a clarification. Is connectivity to the sensors, are they wired, wireless, AMI, cellular, or another kind of connection?
It's not wired, Seth. It's definitely it's through cloud. So I'm not sure that whether it's cellular or through a different cloud protocol, but I can definitely get more information for the audience.
Perfect. Okay. Thanks, Ting. And since I've just had you speaking, I think one more for you as well. When operating the RTC, are there specific challenges that you were aware of for that? Were the challenges maybe known or unknown to you when you began operation?
Yeah, actually, there are a lot of stories about this RTC when the principle and how it operates is really simple, right? You look at the weather and you look at the level and you adjust your valves. But one example is the weather pattern sometimes change. There is one time that the weather prediction was going to have 1 inch of rain in the next 24 hours. And then later the weather changed, but the algorithm wasn't set up to adjusting that when we first did the pilot study. So we were actually going through construction, and suddenly the pond is starting to release the water, which we were not expecting at all. So that's just the algorithm issues that we were working with the OPTI together, saying, oh, we really need to get into be more smart. When there's a false weather prediction, how are we going to solve these problems, and what is the feel-safe plan for that? So I would say one big lesson learned is when you use smart system and this predictions, especially to having a feel-safe plan and thinking through. It takes some time. We did a lot of pilot study, quite some time to fully understand the system, how it works. So I would definitely encourage others to consider the technology when it works and when it doesn't work. What's your plan for doing that?
Great, thank you. One other question, Ken. I know you've certainly outlined a few case studies and given a few URLs for later reference, but are you able to talk a little more specifically around some of the benefits that the wastewater tool provides utilities?
Yeah, I think not only the wastewater tool, but the interactive tools in general. What it allows you to do is to start to create the upfront foundation for your system, and a couple examples of that would be, what is your data architecture going to look like for your entire system? And by developing that data architecture approach, you can start to look at different solutions and understand how they can be integrated into that broader architecture. So you can do this cross-sharing of information as you start to build it. Another area is communications. Utilities have invested a lot in communications, and whether it's radio, fiber, cellular, but over time, communication systems are going to need to be replaced. So part of that process also is what's the communication system I want to have long term, and how do I assure that as I bring solutions in, I slowly migrate over. Again, we have this holistic system that works well together, and that's one thing that SWAN allows you is make those decisions, understand how to create that basic foundation for your system. So as you start to do implementation, at the end of the day, you've got a well integrated operating system. system that's going to serve your needs well into the future.
Perfect. Thank you. One that we've had come in that is good for, I think, all the panel. Of all the stakeholder groups we have, whether it's operators, management, politicians, the public, etc., who are the most difficult to convey the potential of smart systems to, and what do you advise you have to do to overcome this hurdle?
I'll take a first cut at that. You know, having been involved in quality management since the 90s, by far the toughest group is middle management, because oftentimes they are concerned that this is going to take away their control, take away their responsibility, because what you want to do is push knowledge down to your staff and let them make decisions faster. And that's always been a tough group to deal with, and you need to convince them that this is then actually their best interest to be able to put these systems in place and not be afraid of what automation and technology is going to bring.
Great. Ting or Elkin, do you have any comments or thoughts on maybe how you see some of the more challenging stakeholder groups for buy-in are?
Well, they all play an important role here. Upper management needs to be on board and need to understand what are realistic expectations and what are the resources required to get the results. You need to staff your group properly if you're going into that way. I also believe that we need to work along with vendors and consultants. One of the challenges we have with vendors is we need to work together to create some sort of a standardization so we can have integration. And even though I would say that having perfect standard, having a standard is probably a naive thought. We need to at least have guidelines that allow them to understand that we need to integrate the products so we can have something sustainable. So I would say this is not, as I said on my presentation, is the technical part. It might be very simple, not simple, but the easiest out of all the aspects. I think is getting to understand that this is a change in the way we run business, and the role of the people will evolve. We're going from people that may be doing more mechanistic functions into a more data-rich environment in which they have more information to make decisions in a different way. So it's a cultural change.
I would agree with all the levels, and each of these groups of stakeholders having different perspectives and things, thoughts on the smart system as well. So one thing I would talk about on the public side is, part of the smart water platform and the visualization is to really communicate real-time data, whether your wastewater plant data, whether your watershed data to the public. I think it's not a challenge, but just from a utility perspective, we need to really message what is the story here, because that way the public's not just only looking at the up and down trend, and they know whether the watershed or whether the wastewater plant is operating well, because the smart system is only give you the data and the information, but it takes another level to communicate with the public and even the politicians on what is the story you are telling here, what is the actions you are taking that to protect that watershed. I think sometimes we often haven't get to that far, so people may misunderstand your water quality issues or things.
Perfect. Thank you. Yeah, and I think that's definitely just a good way to end it on as well. I mean, this is a broader transformation for the water industry. It does affect a lot of the different stakeholders, and certainly different utilities will experience different communication pain points to different degrees. But it is requiring a good, smart plan to bring stakeholders together. At this point, We've been through the main questions, so what I'd like to do is pass this back to Anna, and she can wrap up the webinar. If anyone does have further questions, feel free to reach out after the webinar, and we'll be happy to help you with that. And again, just lastly, if anyone does have questions about the upcoming workshop in Chicago on the 6th of November, feel free to reach out to me at Seth, seth.cutler, CUTLER at frost.com, and I'll be happy to help. Thanks very much, and over to you, Anna.
Thank you, Seth. Yes, this concludes today's webinar. So again, feel free to listen to the on-demand session for those that have joined late into the webinar. And so the on-demand is going to be available immediately. So thank you again. Thank you again to Elkin Hernandez, Ting, and also Ken Thompson for joining us today. Enjoy the rest of your day.